Okay, students. Okay, welcome back. Everyone's here. Can you hear me? Okay. Okay. Can you see the slide? I mean the Word file. Hi, everyone. Anyone?
I can't.
No.
Cannot.
Cannot.
Oh.
Okay, now you can.
Now
Yeah, can.
Can. Okay then. Okay, guys. Okay, so you had class just now, is it 9 to 10?
yes.
Yes.
Oh, what class?
Maths.
Oh, maths. Okay, guys. Okay, so I'm not going to text you a lot because just finish your AS. Okay, so I go quite. Today's lesson going to be not that much of texting. Yeah, try to finish a little earlier. Okay, so gravitation. So far we done the gravitational field. So what is gravitational field? A region where a mass object experience force. Then we talk about law of universal gravitation. This is what Newton introduced. F equals to gmm over r squared. According to him, the force between two point masses are directly proportional to the product of mass, inversely proportional to the square of the distance. Okay. Then we discussed about these some questions here. You can give a try later. Okay. Then we talk about gravitational field strength. Gravitational field strength defined as what? Force per unit mass, and end up getting this formula. G equals to gm over r squared. Formula to find gravity. These are the two formulas you learn. Okay, now the field near the Earth found to be like this pattern. Okay, if it's more massive and smaller radius, the field gets stronger. So of course, according to what formula? So G equals to gm over r squared lah. Whether the mass get bigger or the radius get smaller, the field must get closer. More lines to be drawn. Okay. So yeah, this is the description. Then finally, end of the last lesson, I told you this is how gravity varies. Gravity out of the surface is curvature going decrease based on, it's called inverse square law. G equals to gm over r squared. The G like proportional to 1 over r squared law. That's why they say inverse square law. Inverse square law. Technically, the gravity never gets zero. Gravity like close to zero at infinity. But in the planet, the gravities become zero at the center. Okay, it becomes zero at the center. Okay. So now the most important we're going to discuss is Earth. You have Earth. We all of us are at the equator now, Malaysia. So we are at the equator. Okay. We are moving around. Okay. Moving around. So now gravity. Okay, gravity affected by three factors. Three factors affects gravity. Okay, other than this mass, radius, there is another three factors. Three factors affects gravity. Okay, the three factors. What are the factors affects gravity? Anyone? Do the people at the equator and the North Pole experience the same gravity? Do they experience the same gravity? Anyone? Different gravity, right? The North Pole and the equator, the gravity is slightly different. Where the gravity is higher? Equator or North Pole?
North Pole.
Anyone? North Pole. North Pole has a greater gravity. Okay. Okay. So what first factor affects gravity? The
Distance.
Yeah. These are the three factors.
Of mass.
These are the three factors affects gravity. The gravitational field strength. I mean the 9.81 is affected by altitude. and depth, latitude, and rotation of the Earth. Okay, these are the three factors affects gravity. Okay, to explain this, let me go back to the PowerPoint. This our class today. Only these three takes about 1 hour. Okay, mainly the last part, rotation of the Earth. Okay, I go back to the PowerPoint. Okay, factors affecting G at the Earth's surface is altitude, latitude, rotation of the Earth. Okay, so first, altitude. Okay, altitude we already discussed indirectly, right? So effect of altitude on G. Okay, so we know gravity is Gm over R squared. Of course, when R increases, G decreases. So therefore, the graph follows the inverse square law. Altitude definitely affects gravity. Not much to say about that. The formula explains that. Okay. So in 1 year, they ask you to plot this graph. Okay, they give a scale. So remember, when R, let's say, is F, to R, the value must drop to quarter F. Be careful when you sketch the graph. You must reasonably drop into quarter F when they become 2R. And so on, for R become 1 over 16, right? The F must drop to 1/16 of the original value. Okay, don't simply sketch at 2R. It never happened quarter F. It happened like half F. You're going to lose mark. Okay, so sketch little sense. Make sure the proposition of dropping is matches with the value. Okay, 2R means the force become quarter. Okay. Okay, next, the depth. The depth on G. Will G approach infinity when R approaches 0? Yeah, we said it's close to 0 lah. Okay, but technically not really. Close to 0. G below Earth's surface. We go into the center of the Earth. This is the derivation which explains why the G go into the depth of the Earth, go deeper into the center of the Earth. The gravity drops. Okay, let's work out this. Okay, as we go below the Earth's surface, the mass of the Earth affecting us decreases. The mass below you is the one responsible for gravity. Okay, what is meant by that? Sorry. Okay, what is meant by that? Okay, let's say we are talking about, if this is the Earth, you are stand here. Okay, so let's say you move depth, you go and stand here now. You already dig the land, you are here. Okay, so the gravity which is responsible, the mass which is responsible for your gravity is under beneath you. This mass. Okay, the mass at the side also gives gravity, but that gravity cancels at the side. Okay, so the mass which is responsible for your gravity, which is pulling it down, is getting smaller. Okay, so gravity is Gm over R squared. So when you go into the Earth, the mass is getting smaller. Okay, so that's why the G equals to G. The mass, they put density times the volume. Volume is 4 over 3 pi R cube. Okay, over R squared. Mass, they change to density times the volume. Volume of the under beneath is a sphere, is 4 over 3 pi R cube. Then they found gravity is G rho 4 over 3 pi R. Those G found to be proportional to R and get into the Earth. So they found, so that's why the straight line region appears inside the Earth. It's going to be G proportional to R. Okay. So because mass under beneath responsible for the gravity. Any questions from here? So this is what the slide explains You go check the PowerPoint here. So G, as we go below the Earth's surface, the mass of the Earth affecting us decreases. Okay, according to the change in volume. So Gm over R squared, the M is rho times V, rho times V, rho times volume. Volume is 4 3 pi R cube, and we could pi R cube. Then we found this equation, and therefore G is proportional to R. Okay, what is the assumption we made for this conclusion? Anyone? this G proportional to R is correct with one assumption. What is the assumption? The assumption is the Earth is perfectly sphere and has a uniform density. These are the two assumptions. If it's not perfectly sphere, you can't substitute as 4 over 3 pi r cube because we assume it as a sphere. And uniform density, because we take the mass, we replace with rho, one simple rho. Okay, so we assume it's a uniform density, then the gravity should be proportional to R. Okay, any questions, guys, from here? So inside the planet, go into the G is dropping because the mass responsible for the gravity is under beneath you getting smaller. The side mass doesn't affect your gravity. They cancel at the side. Okay. Okay. So this is the equation. G below the Earth is G proportional to R. Above is G 1 over R squared. Okay. The Earth is spherical and homogeneous. Homogeneous. This guys, please remember the assumption also. This derivation all with one assumption, two assumptions actually. The Earth is sphere and it's homogeneous. Homogeneous means uniform density. The gravitational field at the center of the Earth is 0. This is because any matter at the center would be pulled equally in all directions, giving a resultant force on it as 0. Okay, so this factor we already discussed. Okay, let's move on to the next one. Okay, next is latitude. Okay, latitude. As you told me, as most of you aware, at North Pole the gravity is found to be quite high. Those who are weighed as 978 at the equator and go to the North Pole, they become 983 Newton, about 5 Newton higher. That means the gravity gets stronger. So why this happens? Why latitude causes the gravity get stronger on the North Pole? Okay, because in reality the Earth is not spherical, but Earth is a little ellipsoidal. It's a little elliptical. Okay, Earth is a little elliptical. Okay, why this happens? Why this happens? Maybe I can. Yeah. Okay, why this happens? Because the Earth is rotating. Okay, like a plasticine. You have a plasticine, let's say in a sphere. Let's say you pivot it at the center. You pierce let's say iron bar at the center, very dense plasticine. You rotate it, just rotate it. You rotate it for maybe 1 year, let's say, keep on rotating it. What happened to this plasticine? It become a little elliptical. It should get a little elliptical. Because of the inertia of the mass, going to make it expand a little out. So it become a little elliptical. In reality, our Earth is a little elliptical. It means what? The radius, the equator radius and the North Pole radius, the R1 and R2, in reality is not same. Which R is greater? The R2, the equator radius is far greater than the R1. Okay, so based on what is the gravitational formula at the surface? The G is Gm over R, what? R. So R squared, right? So when R at equator is huge, the gravity at the equator will become smaller. Okay, at the North Pole, the R is small. So when R small, gravity get larger. So that's the effect. So gravity at the North Pole going to be greater because of Earth is not elliptical. Earth is not perfectly sphere. It's a little elliptical because of rotational effect. The Earth is not spherical, but it's a little ellipsoidal. And the scientists found that the equatorial radius actually exceeds by 21 kilometer. Okay, the equator has a longer 21 kilometer than the North Pole. Hence, measured values of G will show an increase as we proceed from equator to North Pole. So, latitude affects gravity. Okay, gravitational field strength. Any questions from here, guys? You understand? You need to explain this in your exam. They will ask, what are the factors affects gravity? Okay, so the altitude, which exactly can be explained by using the formula. Latitude, just currently, because the reason you should give is in reality, Earth is not ellipsoidal. And third factor is the most factor which frequently asked in exam, is the Earth rotation. Okay? The effect of Earth rotation causes gravity to change. Do you realize that? Okay, let me ask you one question. Now the gravity is found to be 9.81 in your place. Okay, now you're sitting on the chair, your gravity towards the center of the Earth, your place 9.81 roughly. Okay, now you tell me, if Earth stop rotating, what will happen to gravity? Rises, decreases, you get heavier or you get lighter? Anyone? Just give a try. Okay, wrong. I never told you the idea first, but my advice is recall back your circular motion knowledge and tell me, or your general feeling lah, like how Newton feels when the apple fall on his head and develop the entire gravity idea. So like that, can you imagine and tell me, if the Earth stopped rotating, what happened to your weight? Give a try. Come on, anyone can give a try. Wrong, never mind. Just give a try with your reason.
Become lighter.
You become lighter when Earth stop rotating.
Would
Yes.
be the same because it would take a long time for the Earth to become spherical technically.
Oh, a long time to become spherical. Okay, this case, let's say the beginning of rotation, the Earth formed, and the beginning of rotation haven't turned to become elliptical yet. Don't care about elliptical shape yet. Okay, so although let's say it's a perfectly spherical planet and it rotates, the gravity going to drop. The gravity going to, you get lighter actually. You won't get heavier. Sorry, what I'm saying. When the Earth stop rotating, you get heavier. When Earth stop rotating, you get heavier. Why? Okay, let's see that. Okay, let me help you. You have to go to your circular motion knowledge. I believe maybe some of you, please recall back your circular motion knowledge, your centripetal force. Earth. Okay. Recall back your centripetal force. You are at the side, yeah. Okay, come on. What are the force acting on you? So the weight acting towards the center. Then you have a normal reaction acting oppose you. What equals to Fc? Because Earth is rotating, right? Earth is rotating. You need Fc, right? If anything move in a circular path, should have centripetal force, right? One we learn for one topic. So what equals to Fc here? Where's your net force? If you move in a circular path, do you act upon by balanced force or unbalanced force? If you move in a circle, you act upon by balanced force or unbalanced. Come on, anyone? Do you accelerate when you move in a circle? Anything move in a circle, do you accelerate? You accelerate, right? Where do you accelerate? You accelerate towards the center of the circular path, right?
Yes.
So you are accelerating. So if you accelerate, do you act upon by balanced force or unbalanced force? If you're accelerating, unbalanced force, right?
Yes.
You act upon by a unbalanced force. Okay. So now you tell me, when the Earth is rotating, which direction is your net force? To the left or to the right? Towards the center of the Earth or away from the center of the Earth? Your net force.
Away.
Away. Mg bigger or Fn bigger?
Mg.
Anything move in a circular path, anything move in a circular path, anything move in a circular path, it should act upon by unbalanced force. That means the force inside and outside not same. Okay. So force, if it make a circular path, the centripetal force acting towards the center or away? The centripetal force towards the center, right?
Yes.
Always act towards the center. So the net force is towards the center or away? The net force also towards the center. The centripetal force is the net force lah. Okay. So in this case, because you're moving in a circular path, the force towards the center should be bigger. So what equals Fc? Mg minus Fn or Fn minus Mg? Anyone? Because you move in a circular path, you are accelerating towards the center. That acceleration is called acceleration. You're accelerating towards the center. So Mg minus Fn is your Fc. If you consider Earth rotation, Earth rotation. Okay. So this the formula must come to your mind by using your circular motion knowledge. The circular motion knowledge. Okay. What we are discussing now? We're discussing how gravity affected by the Earth rotation. Right? Okay, now I want to ask you one question. You are at the equator now. You stand on a weighing scale. Okay. You have a weighing scale here. You have a weighing scale. Okay. The weighing scale gives a reading, a certain reading X. Okay. That reading is equals to which reading? Your weight reading. Your Mg, your Fn, or Fc?
FC.
When you stand on a weighing scale, you read the weighing scale reading, give your weight, let's say it gives you 800 Newton. Okay, 800 Newton. We practically, everyone take this 800 Newton as your weight, right? Weight. But scientists who know that considering the Earth rotation, the scientists will consider it as an apparent weight. This is your apparent weight. What is meant by apparent weight? This is the weight you feel. The weight you feel. But in reality, your actual weight is different. Like lift. You are in the lift. You are in the lift. Okay. You are standing in the lift. Let's say you have a weighing scale at the bottom of you. Okay. When the lift accelerate, what happened to the reading on the weighing scale? Change or same? Change, right? It depends to the how big is the acceleration of the lift, right? When you accelerate up, the weight gets larger, right? This reading is called apparent weight. It's called apparent weight. The weight you felt at that moment. Okay. So the weighing scale reading is which reading? Mg, Fn, or centripetal force? Okay, this is important. Fn. It's actually your normal force. The rating you did by the weighing scale is your normal force, normal reaction. You're standing on the weighing scale, you press the weighing scale machine, the scale pushes you up, it gives the reading. It's the normal force. Okay, so the reading you read from the weighing scale is your normal force. But which is this call is your apparent weight. This is your apparent weight. Okay, this is your apparent weight. Okay. Okay, now this mg, right? This mg, this is your weight, your real weight, real weight. Okay, now make the Fn as the subject. Make Fn as the subject. Fn equals to, make as the subject. How's the equation going to change? It's going to change mg minus fc, correct? Mg minus fc. So Fn equals to, mg is actually your gmm over r squared, r squared minus fc. Fc what formula? mr omega squared. I can put mr omega squared. The one you learn in circular motion. Okay, mr omega squared, or you can put mv squared over r if you want. Okay. Now, whatever reading on the weighing scale is found to be Fn. This Fn we equate as mg. We found our gravity as 9.81. Okay. We use the Fn, normal force. Okay. You now tell me, normal force, this is the formula. What is the normal force now? Normal force equals to mg minus fc. Minus fc. Okay. Now tell me, when the Earth stopped rotating, what happened to fc? When Earth stopped rotating, what happened will have fc? Fc will become 0, right? When fc becomes 0, what happened to Fn? Increase or decrease? Guys, I need your response. When fc becomes 0, what happened to Fn? Increase or decrease?
Increase.
So Fn increases. Fn increases. So Fn increases means what do you think? You get heavier. You get heavier. So So your reading on the wing scale increases. So mg, your g looks like greater. Your apparent gravity looks like gravity. So gravity affected by centripetal force. Centripetal force happens due to Earth rotation. Due to Earth rotation. If Earth stop rotating, you will get heavier. How heavy you can be? What is the maximum heaviness you can be? Fn equals to your mg lah. Your Fn going to be equals to the maximum you can go is your gmm over r squared. And that's the maximum you can go lah. This is your gmm r squared is your maximum gravitational force you can attain. Okay, but because Earth is rotating, the Fn smaller than gmm over r squared. So you like lighter. Okay, if Earth is rotating faster, let's say some what do you call some universe reaction causes the Earth to spin faster due to some collision or something. When it gets faster, what will happen to your weight? You'll get even lighter. So that's the third factor. What are the factors we are testing here? We are testing how gravity affected by Earth rotation. Ask, I think, twice in exam. One full complete structured question. 7 to 8 marks. They ask how gravity affected by Earth rotation. This entire description has been tested for 7 to 8 marks. Okay. So, conclusion, let me clear this. So, in your AS, you stand at the equator. We never consider the Earth rotation. Never consider the rotation. We never consider the Earth rotation. We said mg Fn is same as mg. That's what we use in AS. Okay, but now in A2, especially in gravitation topic, only in gravitation topic, because we are considering Earth is rotating, then by using mg, I don't put mg, I put gmm over r squared Fn, because it's rotating. So we found that Fn, gmm over r squared minus Fn is found to be Fc. So the normal force is found to be gmm over r squared minus Fc. Okay, this is your new idea. If you consider Earth rotation, this is considering rotation. This is not considering the rotation. So any part you don't understand? Anyone? So you can understand, hope. So the reading you detected from the weighing scale is Fn. Okay. The maximum Fn can go is gmm over r squared. When that happen, when Earth stop rotating, when Fc is getting 0, then your Fn going to be maximum. That's it. Okay. Yes. Any questions? Anyone? No questions. Oh, you understand? Okay. I got back to the Earth rotation. Effect of Earth rotation. The Earth rotates about a polar axis, hence masses on the surface of the Earth rotates in the circle, decreases radius from the equator to the pole. G is minimum at equator, where the centripetal effect is the greatest. Centripetal effect is the greatest. Mr omega squared. G is maximum at the poles, where centripetal effects are not felt. Yes, correct. Do you understand the last 2 points? G is minimum at equator, where the centripetal effect are the greatest. G is maximum at the poles, where the centripetal effect are not felt. Why the equator, the centripetal effect are the greatest? Anyone can explain to me? Why the centripetal effect is greatest at the equator and the centripetal effect is not felt at the North Pole?
Highest
Anyone?
velocity.
Is it velocity? Oh yeah, good. Can say highest velocity. Based on what formula? Again, Fn equals to what? Fn equals to what? Gmm over r squared. Okay, sorry. think I go to the whiteboard, be easier. Okay, so Earth at the equator, because it's rotating like this, okay, the radius of rotation like this. At the North Pole, if you are here at the point A, the rotation cycle is only here, the radius gets smaller. Rotational radius, radius of rotation radius. So for this, the normal force equals to what? Your GMM over R squared minus M R omega squared. Okay. So here also it follows the same formula, but point A and equator, point B, okay, I think F at A bigger than Fn, sorry, Fn at A is bigger than Fn at B. Why? Because of the radius. You see, when the radius get bigger, the centripetal force get bigger. So the centripetal effect is dominant at the equator. At the equator, the centripetal effect is quite big. The centripetal force is quite big because radius is big. Or you can use another formula. Another centripetal formula is what? mv squared over r. Okay. This is very difficult to tell because v changing, r also changing. I think best is mr omega squared. So r is get bigger. Omega same. Omega a and b same, right? Why omega same? Omega is 2 pi over period of rotation is same. So omega is same. Omega a same as omega b. So omega is same. So when r get bigger, the centripetal effect get bigger in the equator. So the normal force smaller. So apparent weight smaller at the equator. That's the idea explained by this. G is minimum at equator, where the centripetal effect are the greatest. The centripetal force is the greatest because R is big. Okay, so G is becomes small. Gravitational field strength becomes small because Fn is small. Fn equals to mg. The G becomes small. Okay, here G become maximum. So rotational effect reduces the gravity successfully. Okay, so conclusion: what you learned today? The most important factor: what affects gravitational field strength? Altitude, latitude, rotation of the Earth. Okay, the most important factor they're going to ask a lot is the rotation of the Earth. Remember, rotation of the Earth is the one the most they're going to ask. Okay, altitude has been explained by using the formula itself, gm over r squared. Latitude, just now I told you, Earth is a little elliptical. Latitude affects the gravity. Any question, guys, so far about gravity? The factor affects the gravity. Okay, no. Let's move on. Okay, so I skip this. Just some questions. Okay. Okay. In your A2 examination, paper 4, which carries most of the marks, when you open up the paper 4, the first question you're going to be exposed is gravity. And the gravity normally won't be together. It won't be like a lone ranger. It always together with circular motion because all planets are moving in a circular path. So circular motion, gravity together will give one structured question. Okay. So whenever you do gravitational question, you have to recall back what you learned in circular motion last time. Okay. The Fg equals to Fc. Okay, guys, come on. Let's try it together. I give you 1 minute. Read these questions. Try to figure out how you're going to go about with this question. 1 minute for you. Get the ideas. Okay, guys. So I hope you have some idea. Okay, so I need your input. Okay. So Earth is mass given, maybe assumed to be a circle radius. Circle radius. The sun at its center. Okay. The time taken for one orbit is 3.2 times 10 to the power 7 seconds. Calculate the magnitude of the angular velocity of the Earth about the sun. Okay, A1. What formula do you use to get the answer? This is your circular motion knowledge. Anyone still remember? What is the angular velocity? Omega. How do you find omega of the Earth about the sun? Earth, what is the omega of Earth going around the sun? What is the omega formula? 3 omega formula you learn. Omega is theta over time. Another 2 important one, 2 pi over, anyone? 2 pi over period. Then another third formula is what? 2 pi f. Yeah. So the magnitude of the angular velocity of the Earth about the sun is, which formula to be used? Because period is given. Use 2 pi over t. Use 2 pi over t. 2 pi divided by 3.2 times 10 to the power 7 seconds. You get omega. Omega. What is the unit for omega? Anyone? Radian per second. Sorry, I think something's wrong. So radian per second. Radian per second. Okay, good. Next to what formula? The magnitude of the centripetal force acting on the Earth. What formula do you use? So centripetal force, 2 formulas. Tell me what's the formula for centripetal force? mr omega squared, or another one is what? mv squared over r. So which formula do you use to find the centripetal force here? mr omega squared. Because A1 you know omega already. What r do you use? Is 1.5 times 10 to the power of 11. R you know. What mass do you use? Mass of what? The magnitude of the centripetal force acting on the Earth. So this should be mass of the Earth. It should be mass of the Earth. You get the centripetal force acting on the Earth. So mr omega squared to be used. I think part A entirely has circular motion knowledge. Okay. Now comes in the gravity knowledge. B1. Anyone? State the origin of the centripetal force calculated in A2. What's the answer? What contribute to the centripetal force here? Anyone? Because if you learn the last circular motion knowledge, Fc is contributed by some forces. Here, what force contribute to the centripetal force? The gravitational force between the gravitational force of sun on the Earth. It contribute to the centripetal force. Okay, the gravitational force of sun on the Earth contribute to the centripetal force. Okay, that's a B1. Okay, last, determine the mass of the sun. Okay, now I leave it to you. How do you get the last one? What equals to what? You get the last answer. Anyone? What equals to what? You get the last answer. Mass of the sun. Centripetal force equals to the gravitational force equals to the centripetal force. The gravitational force of the sun and the Earth equals to the centripetal force. So from here, can you work out the mass of the sun? Yes. What is the gravitational force formula? mm over r squared. It's equals to centripetal force. Centripetal force, you already know the value. This capital M is for the mass of the sun. The small m is go for mass of the Earth. This r how much? What is this r? R between the orbital radius between the center of the sun to the center of the earth, which is 1.5 times 10 to the power of 11 meter squared. You can work out the mass of the sun. So point here is gravitational force between the earth and sun is equals to the centripetal force of the earth. This is 1 mark. The equation is 1 mark. Substitution will give you final answer is 1 mark. This is how you visualize it. First part, circular motion. This is how the working. So angular 2 pi over t, mr omega squared. The gravitational force due gravity. Gravitational force between the earth and the sun contribute to the centripetal force. And F equals to gmm or r squared. So you get the mass of the earth. You guys, any question? So I hope you understand this slide. Okay. Okay. So this is the last slide for today. Okay. You finish part D, then we can stop. Okay. Again, 1 minute for you guys. Come on. Last slide. You do fast, we can stop faster. Give a try. 1 minute for you. I'll give you 2 minutes, quite long. Okay, write your answers in a piece of paper. Use your circular motion knowledge and gravitation knowledge just now, you know. F equals to gmm over r squared. Gravitational field strength is gm over r squared. Your circular omega is 2 pi over t or 2 pi f. Centripetal acceleration v squared over r omega squared. Centripetal force r omega squared or mv squared over r. Okay, class. So I hope you have some idea, maybe the early parts. How do you do A1? So this is a binary star. You heard of binary star? Binary star means in our galaxies, of course, we have our sun. There are a lot of planets rotating the sun. Binary star, only two suns maybe. They are rotating among themselves. Only two of them. They are rotating among themselves due to their gravitational force between them. It's called binary stars. Okay. The binary stars of two stars, one is quite massive M2 is massive, M1, M2 is massive. We don't know. One is massive, one is less massive. One is R1, one is R2. R1 is shorter than R2. So it's moving in a circular path. First, state the formula in terms of G, M1, M2, R1, R2 in omega. The gravitational force between the two stars. What's the answer? G, M1, sorry, yeah. G, M1, M2 in bracket, R1 plus R2 squared. Do you got this answer for the first one? Why we go for R1 plus R2? Because we want the force between them, the gravitational force. The distance separated by them is R1 plus R2. So R is R1 plus R2 squared. M1, M2 lah. That's the first answer. G M1, M2 over R1 plus R2 squared. Gravitational force. Next, what is the centripetal force on the star on M1? How much is the centripetal force acting on the star M1? What is the centripetal force formula? Centripetal force is mr omega squared or mv squared over r. Because here they give in terms of omega, they want in terms of omega. So we go for mr omega squared. Centripetal force on star M1 is M1 R1 omega squared. Okay. They want only for M1, right? M1, yeah. Should be only M1 R1 omega squared. That's the centripetal force for M1. Its own mass, the radius it makes in a circular path, omega, its angular velocity square. Okay. So state the formula in terms of this. The centripetal force on the star is mr omega squared to be used. Okay, B, the star orbits each other in times of this, or this is the period given. Calculate the angular speed of omega. What formula to be used? Anyone? Omega period given, so what is the formula? 2 pi over t to be used. So C, reference to either, sorry, C, 2 pi over t. Put the period 2 pi over t to be used, so get the omega 4.99 times 10 power negative 8 radian per second. Very small planetary system. Okay, so we got omega, we got gmmr squared, mr omega squared formula C1. Show that the ratio of masses of the star is given by M1 over M2 equals to R2 R1. Prove this equation. How do you get this equation? M1 over M2 equals to R2 R1. How do you get this equation? So how to get this equation? Because they are moving in a circular path, their centripetal force equals to the gravitational force. So the both centripetal force must be the same because both has the same gravitational force pulling towards them. So conclusion is the M1 R1 omega is equals to M2 R2 omega. The centripetal force for both of them same. So from here you can rearrange, get the formula. M1 over M2 must be R2 R1. More massive star must have a smaller radius. Okay. The ratio of M1 M2 is equal to 3. And the separation of the star is this much. Calculate the radii of R1 and R2. M1 and M2 they give already 3. Now they want to calculate R1, R2. So how do you calculate R1 and R2? Now you need to bring the gravitational force. So C, C1, C2. This is R1. So R1 is this much minus, so get the answer. How they got this formula? R2 we know, or we calculate the R2 first, 3 over 4. The R1 is actually total minus R2. Total distance, you know what? R1 plus R2, you know already. So you know R1 plus R2 already. What? R1 plus R2 is what? R1 plus R2 is which distance? Oh yeah, they give the distance what? 10 power of 11, 3.2 times 10 power. So, you know, R1 plus R2, you know, 3.2 times 10 power of 11, first equation. Second equation is this one, M1 over M2 equals to R2 R1. M1 over M2, they give 3. So you can find, so second equation is R2 over R1 equals to 3. So this is the second equation. After that is maths what? 2 unknown with 2 equations. You can solve the equations. Okay, so that's the answer for this. Okay. And finally, by equating the expression, you are given an A, using the data, calculate B and C, determine the mass of one of the star. So you know the R1, R2 already. They want mass of one of the star. How do you get it? Equate with the gravitational force. See, mr omega squared, m r1 r2 squared, m2 m1, massive stars. Yeah, so use the gravitational field strength to calculate it. M2 is this ratio. Get the answer. Okay. So you can figure out these equations. This is like one structured question. Okay, this is like one structured question. The GM over R squared. Yeah. GM over R squared. Yeah. This formula is appeared from where? FC equals to FG. The M1 R1 omega squared equals to G M1. Sorry, can't write. I write here. Is equals to G M1 M2 over R1 plus R2 squared. From here, you get the first line here. So from here, you can work out the mass because M1 cancels. You can get the M2 value. R1, R2, all you know what. So you can find the mass. Less massive will have a greater distance. Okay, so that's all part 1 of gravity. Any questions, guys? So you learn what you learned so far today. What you learned today is what affects this G: altitude, latitude, rotation. Okay. Then after that, we did some question, and I told you that circular motion always together with circular motion. As a gravitation always together with circular motion. So you have to recall back your circular motion knowledge. Okay. So overall, today you learn about gravity. Okay, so learn about gravity. So F equals to GMM over R squared. G equals to force over mass, GM over R squared. Gravity affected by 3 factors: latitude, altitude, and rotation. Okay, these are the things you learn. Any questions? Okay, try to revise this. So Monday we will continue. Any question, guys? Okay, I know it's after your AS, you are really got a hard time. Just finish your exam, then suddenly your classes. Yeah, I do understand your feelings. Okay, so no choice because your A2 is in April. But anyway, have a great weekend. So I see you on Monday back. Okay, bye. See you.